Ratio test for positive series. Let's suppose that we have a positive series sigma an, and let's suppose that the limit of an plus 1 over an is a real number L. Then we have three cases. Case number one, FL less than 1, then sigma an converges. FL bigger than 1, so sigma an diverges. FL equal 1, then no info. What is the meaning of no info? This means in some exercises, the limit will be 1 and the series diverge, and in other exercises, the limit of an plus 1 over an equal 1, but the series converge. So no rule about this case. Okay, we have also another remark here. FL equal infinity, then infinity bigger than 1, and the series diverge. So remark, that f limit an plus 1 over an, and n goes to infinity. If the answer is infinity, then sigma an diverges. The answer is infinity. So now for positive series, the word diverge or equal infinity is the same. But if the series is not positive, so maybe it diverge, but it's not equal to infinity. In this case, diverge means it doesn't exist. If it's not equal to infinity and diverge at the same time, so the answer of that series doesn't exist. Let's take some examples. Exercise number 1, test the following series. The first one is given here. So let's suppose that an is 3 power n over n factorial. And let's calculate an plus 1 over an. What is an plus 1 over a? It will be 3 power n plus 1 divided by n plus 1 factorial divided by 3 power n divided by n factorial. What is the meaning of factorial? Let's write here in blue. So 3 factorial is 3 times 2 times 1. And 4 factorial, it's 4 times 3 times 2 times 1. And if we divide 4 factorial over 3 factorial, so we will have 4. Okay? Or we can write 4 factorial could be written as 4 times 3 factorial. Okay? So after writing 4 times 3 factorial over 3 factorial, after cancellation, it will be 4. So let's write some rules like this. N plus 1 factorial equal n factorial times n plus 1. And also n plus 2 factorial could be written as n plus 2 times n plus 1 factorial. And also it could be written n plus 2 n plus 1 times n factorial. And finally, we can write n plus 1 factorial over n factorial. The answer is n plus 1. Okay, we need these formulas and these rules in the following exercise. So let's delete here, this term with this term, it will have 3 here. If we delete this term with this term, we will have n plus 1 using this formula here. So we will have 3 over n plus 1. What is the limit of this term when n goes to infinity? The answer is 0. So this is L less than 1 using the previous rule about ratio test. If the limit of an plus 1 over an, any number could be 0, no problem. Any number less than 1, so this series converge. So by ratio test, sigma 3 power n over n factorial from 0 to infinity converges. Or this means it's less than, it's a number less than infinity. Let's see the next exercise. So here I have an, it's n power 7 over 5 power n. So let's calculate an plus 1 over an. It will be n plus 1 power 7 over 5 power n plus 1 over n power 7 over 5 power n. Let's delete this number with this number. We will have here 5. And let's delete also this term. We cannot delete this term with this term. Okay. Wait a minute. So we will have here, after deleting, 1 over 5 times n plus 1 over n power 7. So what is the limit when n goes to infinity? It's 1 over 5 times 1 power 7. So the final answer is 1 over 5. It's less than 1. Now, by ratio test, so sigma an from 1 to infinity converges. The next example here, if we take, this is an, sigma an, we take an plus 1 over an, we'll find 2 power n plus 1 over n plus 1 over 2 power n over n. We can delete this term with this term. We will have 2 here. After that, we will have here 2n over n plus 1. So the limit of this term when n goes to infinity will be 2. 2 is bigger than 1, so sigma an diverges. Or we can write this is equal to infinity, from 1 to infinity. Method 2, we can solve this exercise using the nth term test. What was the nth term test? Let's remember. Let's repeat it here. If the limit of an when n goes to infinity is not equal to 0, then sigma an from 1 to infinity, for example, diverges. So how to calculate the limit of 2 power n over n when n goes to infinity. To find this, let's calculate the limit. So to find this, let's calculate the limit of 2 power x over x when x goes to infinity. So here it will be infinity over infinity in determinated form. So let's use L'Hopital rule. So it's limit of the derivative of 2 power x. What was the rule of the derivative of a power x? It's a power x times ln a. So it will be the limit of derivative of 2 power x. It's 2 power x ln 2 divided by derivative of x. It's 1 when x goes to infinity. Now if I put infinity, it will be infinity. So the answer is infinity. So because the limit for x is infinity, so also the limit for n is infinity. The limit of 2 power n over n is infinity when n goes to infinity. So because this limit is not equal to 0, so the limit of an is infinity. So this infinity is not equal to 0. So now using nth term theorem or test, it's right, in term test, sigma 2 power n over n when n goes to from 1 to infinity diverges. The answer is infinity. So here we are using rule said that the limit, if the limit of fx when x goes to infinity is infinity, then the limit of fn where n goes to infinity also will be infinity. Here x is continuous, it moves on in r, but n moves in z. So n is 1, 2, 3. It will not be n, it would not be a half, but x could be a half. So this is the difference. Okay. Now the next exercise. Here I will suppose this is sigma a and this is from 1 to infinity, for example. So let's take an plus 1 over an plus 1 over an. Let's calculate. So it's n plus 1 factorial over n plus 1 power n plus 1 over n factorial over n power n. So let's delete n factorial with n plus 1 factorial here. After deleting, I will have here n plus 1 up. So let's write here I have n plus 1 up over n plus 1 power n plus 1 could be written n plus 1 power n times n plus 1 over 1 over n power n. So we can also cancel this term with this term. So after cancellation, I will have n power n over n plus 1 power n. So all of that power n. So now what is the limit of this term when n goes to infinity? Inside it's 1 and here infinity, 1 power infinity. Is it 1? No, it's not 1. It's indeterminated form. So this is indeterminate form. So how to solve this problem? So let's continue. Let's write this term equal. I can write here 1 over n plus 1 over n power n. So this is equal 1 over n over n, it's 1 plus 1 over n power n. Now, what is the limit of this term when n goes to infinity? We have a rule, if you remember, that it's the limit of 1 plus 1 over x power x. When x goes to infinity, the answer is e, the Neperian number, nearly 2.7. So here the answer is 1 over e, so nearly 1.2.7. So it's something less than 1. So now by ratio test, we will have sigma n factorial over n power n from 1 to infinity converges. The last exercise, let's support this term sigma an from 1 to infinity. So let's calculate an plus 1 over an. So it will be, let's see here, n plus 1 factorial power 2 over 3n plus 3 factorial. Because here, instead of n plus 1, it will be 3n plus 3. Okay. Over n factorial power 2 divided by 3n factorial. Okay, let's continue. Let's write here so let's write here up. I have n plus 1 factorial times n plus 1 factorial divided by 3n plus 3 times 3n plus 2 times 3n plus 1 times 3n factorial divided by n factorial times n factorial divided by 3n factorial. Let's delete this term with this term, and also we can cancel this with this. I will have n plus 1, cancel this with this, I will have n plus 1. So after cancellation, I will have up n plus 1 times n plus 1. And down, I will have 3n plus 3 times 3n plus 2 times 3n plus 1. So here down I have n power 3 up n power 2. Okay, so if I write, it will be n power 2 plus blah 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 over 27 n power 3 plus blah blah blah. So the limit of this term when n goes to infinity, it's 0. Because the answer is less than 1, so by ratio test, my sigma n factorial power 2 over 3n factorial from 1 to infinity converges.